people, back at it again. Now we're doing geometric sequences. Geometric sequences are like one of my favorite sequences. They are amazing, amazing, really amazing. So geometric sequences, let's just have the general formula of a to the n. They might have a to the n plus constant, but they usually just have a to the n. So now, what we've noticed about the series is that when we have a arithmetic sequence, it's Tn equals to Dn plus C. When we have a quadratic sequence, it's Tn equals to An squared plus Bn plus C. Now we are dealing with geometric sequences which have Tn equals to A to the n plus C. So now you know that an arithmetic sequence is a linear sequence. It follows, all of them start at 1, so it follows this trend. The quadratic sequence is a parabolic sequence which follows this trend. And now the geometric sequence, I think you would have guessed already, it's a hyperbolic sequence which follows some trend like this, like that, you know, or whatever. Always has an asymptote. I mean, and it's not really an asymptote because it has discrete numbers, but it would look more like a hyperbola. Hyperbola. Is it a hyperbola? No. What is that? Oh, no, not a hyperbola. I'm sorry. Exponential. Yeah, it's something like that. I don't know. Let's call it exponential. This one is a parabola. And this one is a linear or straight line. So yeah, yeah. So geometric sequences are my favorite because they usually either approach two values. They usually approach at sum to infinity. Usually approaches either infinity or uh like some constant value. It usually approaches infinity, but it doesn't approach infinity, and we'll show you why it doesn't approach infinity, but it usually goes to like infinity and stuff. So yeah, let's just jump into it. So so Tn would be either An plus C. This plus C is really probably would be added to the An or not added to the An. You probably have seen it in the general formula of A R n minus 1 or Rn. So n minus 1, n would start at 2, of course, because, okay, even if n starts at 1, but you know, it's just usually considering like the first term for that. So yeah, or you can just have a r to the n. It really doesn't matter. It's just a point of where you're starting, but it's kind of the same. So let's just jump into the first example. I'm sorry for saying that cringy line all the time, but if we have an example of 1 over 2 1 1 over 2 1 over 4 1 over 8, we kind of see where this is going. So to find r, you have to say r equals to 1 over 2 over 1, and it has to also equal to 1 over 4 over 1 over 2. It's kind of a checking method if this is really a quadratic equation. You see a quadratic equation is multiplied by something to get the next term. Yeah, and r equals to 1 over 2. Of course, 1 over 4 is 1 over 4 times 2 over 1, which is 2 over 4, which equals to 1 over 2. So yeah, and to get the first, a is the first term. You see the thing is 1 over 2. So if we write it in terms of a n equals to a r to the n, we have r as 1 over 2. So 1 over 2 times 1 is 1 over 2 to the power of 1 is 1 over 2. And a in that case would be, because this is 1, this is a, this is 1 over 2, a would be 2. In the case where you use this, a would be 1. Uh, a would be 1. And you'll have 1 over 2 n minus 1, because you're going to have n to the 0 in there. So it is very confusing on if you use this equation or that or this equation. Why do you say use this equation? Because that's what like the standard uses. Here you just start at 1 and then you change the thing, but because generally they say a is the first term, you usually are not told how to start with n, but a is the first term. Yeah. So yeah, yeah, I mean the first term can be anything you want it to be, but use the general equation. So we're gonna take this as Tn equals to 1 over 2 n minus 1. The reason I'm saying that a doesn't matter is because of this. If you have Tn equals to 1 over 2 n times 2 and Tn equals to 1 over 2 n minus, you have essentially Tn equals to 1 over 2 n times 1 over 2 minus n. And the inverse of this is just 2 1 over 2 n. That's what I'm saying. Hold on. It doesn't matter, but it matters. I really don't know. I think you should ask your teacher on which one they prefer. I prefer you use this one because I think it's like the standard one for mathematics and metric, but you'll still get the same answer because these two answers are the same. I can just literally inverse this and say it's 2 and minus that, it'll still be the same answer. So whatever n term you'll have, if you have n equals to 2, you'll get the same answer. N equals to 1, you'll get the same answer. It's just the whole thing. Yeah. The whole shtick. So we can do one more example and we'll kind of close this chapter. We'll do one more example and we'll go to what usually is more important in so I'm gonna write it like this, Rn. So or yeah, so we're gonna write it. Okay, let me just use one sequence so I don't confuse it. We're gonna write it like that. So we can have an example. We'll talk about soccer. So this is kind of a long example. So in soccer tournament, we have